Storware Backup and Recovery supported oVirt-based virtualization platforms for many years. My name is Marcin Kubacki, I'm Chief Software Architect at Storware, and in this video I'm going to show you how to protect oVirt, Red Hat Virtualization and Oracle Linux Virtualization Manager. I'll start with logging into the Storware Backup and Recovery. And the very first thing you see is the dashboard. Dashboard that basically shows you general statistics about your nodes. Nodes are the data movers in the Storware Backup and Recovery, your activity and overall protection. In the Virtual Environments tab, that's actually the core part of the OLVM, oVirt and Ref data protection. So in the virtualization providers, you are able to add more providers to Storware Backup and Recovery. I have already one Oracle Linux Virtualization Manager added, but notice that when you add oVirt, Ref or OLVM, you have to specify several things. Of course, API URL and your credentials, but one of the things that is quite unique in Storware Backup and Recovery are backup strategies. We support several backup strategies. The latest is change block tracking, so that requires the newest version of the oVirt-based environment, but it has the advantage that it doesn't require to persist snapshots and to keep them on for longer time in the virtualization platform. If that's not your case, you still are able to use Disk Image Transfer API, which also has been optimized in our oVirt-based environments for some time already, and while it still requires snapshot to be available for the incremental backups, you don't have to do anything in terms of the setup of the infrastructure. We are able just to connect to your manager, and data transfer occurs directly from the hypervisors through the appropriate agents. Agents that are, well, to be honest, it's actually a proxy running on the hypervisors, but it's built into the oVirt itself. If you are willing to use the disk attachment method, that also supports you the option to do full backups and to deploy a nodes directly on the virtualization platform. The advantage is that in this case the transfer occurs directly over your SAN network, because we attach directly the disks to our proxy virtual machine. Now, the node configuration is something that is related to the topology, how we deploy our solution. We will cover that later, but that's one of the things to consider if you have to follow with disk attachment method. Other than that, it gives you just the option to specify the same settings for multiple data movers that we have in our environment. Once you have connected to your hypervisor manager and you have run inventory synchronization job, that also is being done periodically to refresh your environment, you will see that gradually information appears. Especially most important is the tab for the instances tab, actually, where you see all of the virtual machines that are present in your environment. But in inventory synchronization actually adds more details to this inventory here, and notice that you will see also the hypervisors that are present in your environment. That's also the place where you can override and specify different set of nodes that are going to handle backups for virtual machines residing on this particular hypervisor. Especially useful if you have multiple clusters. But also you will see, well, the clusters, the storage domains that have been already scanned, networks that are present in your environment. All of these are scanned during the inventory synchronization. Progress of the tasks you can notice here at the bottom of the screen on the task console. So you can see that I have two workflows, and this workflow actually has single task inside. And once it is successful, you see obviously all of this information collected. Now, this is my test virtual machine. I have already assigned a policy, a default policy that basically have some retention settings, schedules already configured, and my single backup destination. Let's run the backup for now. I can run in incremental backup in this moment. I can obviously also specify retry count. If you have more backups running simultaneously, you may consider of using retry option if your workloads, if your environment is heavily loaded. And in case of the failure, we will retry automatically individual backup. This also creates a task in the console. We have another workflow, and the first step is the export task. Export task basically grabs the data from your virtualization platform in some way that depends on the strategy, and exports it to the staging. Once the data is on the staging, it is transferred to the backup destination. Policy that I have actually mentioned, notice that has several options already configured. This is the place where you can actually specify if you would like to which virtual environments are going to be protected. Some specific options for the backup process, like quiescing the file system or scanning the file systems for the later file level recovery. But in general, important section is here, the rules section. In the rules section, you can define multiple processes for the backup. Each rule corresponds to a single backup process, and this process can actually keep backups in one backup destination or optionally store data in the secondary backup destination. The requirement for such setup is that your primary needs to be synthetic. This is also the place where you specify the retention settings, so for how long the backups should be kept, and optionally, if you would like to limit the number of versions, for how many versions of your backups are going to be kept in your backup destination. There is also immutability backup option, so you may enforce that for a specific number of days backups will for sure be kept, and there will be some mechanism used related, let's say, to the backup destination on underlying storage, such as, for instance, retention log for the data domain or immutability flag for the XFS file system. That is actually another option to secure your backups against ransomware attacks. Now at the bottom of the screen you define the schedule, so when your actual full and incremental backups are going to take place and how long they are allowed to start. Okay, so if you specify, let's say, at 6 p.m. like in here, we assume here that for the next 6 hours you will allow backups to start. Once they have started, you will allow them to continue. You can obviously define more rules if you wish to. So let's say periodic monthly backups, they could actually be defined in here. And let's look at our backup process. Backup process have just been completed. So notice that once the export has been done, then there was a store phase and several cleanup tasks to clean up both staging and snapshots in the hypervisor, if there were any. In the instances tab, notice that here in the details you will have the option to see the activity statistics, especially related to the backup size, backup time, which phase took longest, and if there were some restores, like I did in few times during the past day, you will see which phase actually took the longest. That's especially useful if you would like to optimize your backup process and see that, well, let's say your export phase takes majority of time, or maybe your store phase actually takes more and more times, and then maybe you should consider to change something in your infrastructure. There are some additional settings in here available for virtual machine, like to provide credentials to your operating system inside the virtual machine. It's not required, but if you would like to enable pre-snapshot and post-snapshot custom commands, you can also do that. So we support QoS, so let's say free file system capability of the oVirt, but if it's still not enough, you can invoke custom commands over SSH. Here also in this section you are able to exclude individual drives and run specific operations such as backup, restore, and mount capabilities. Now, for the recovery, as far as the recovery process is concerned, notice that I have several options. The very first one is the very basic restore to the hypervisor. So there will be a set of tabs in here, and you will have to respond, like for instance, if you would like to rename the virtual machine, to which virtualization provider you would like to import this virtual machine. You may actually import to the other Oracle Linux Virtualization Manager or oVirt. That's supported. You may also change some configuration related to your disk drives, or exclude them at all if you don't want to import them. Networking and some other advanced features like power on, let's say, a virtual machine after it has been restored. The additional option is to obviously to restore to the node. That's actually giving you raw data. If you wish to check raw data of your virtual machine, like the metadata, like the drives, that's the option for you. And here it's a quite new feature. It's instant recovery for the Oracle Linux VM, oVirt, and ref environments. And let's invoke this one. So here I have majority settings actually the same as for regular restore. So I also specify which virtualization provider needs to be used. Storage tab is slightly different because in this case I don't have option to customize this layout, but I'm able actually to specify if I would like to invoke live migration just after it has been powered on actually in the environment. So instant recovery basically runs backups directly from Storware Backup and Recovery node, so backup destination is in this case, but you may wish to automatically invoke live migration process. So that's up to you if you wish to invoke it directly from here, later from the mount and backup section, or you may just want to have that temporary virtual machine that is going to be removed after some time. Networking, it's the same. You just provide the configuration for your network cards, and let's power on VM directly after restore, summary, and restore. Again, that's the restore workflow that you see in the console. So let it work for a moment, and notice that I also have another entry here called mounted backups. It's the same section actually used for file level recovery, which we are going to see later. In the meantime, let's look on our Oracle Linux Virtualization Manager. So here in the compute and virtual machines, notice that I have still the same virtual machines that we have seen in our original list. And in here, the domains section, notice that I already have temporary storage domain that has appeared for the instant recovery process. It's already up. I already have my virtual machine starting up. So notice that it took just a few seconds to actually invoke the process for the power on of the virtual machine. And from now on, you can actually play with this virtual machine, check if everything's running inside, without the need to restore whole virtual machine, which can sometimes be a few terabytes in size, and the restore process would take very, very long. Mount operation is still in progress. Okay, so here it is reporting that tools are already in there, and now behind the scenes we invoke live migration. So that's the toggle that I have enabled during the restore process. So my virtual machine now runs from Storware Backup and Recovery, but in the background Oracle Linux Virtualization Manager actually is going to to migrate data for me. So notice here that tasks that happening inside Oracle Linux VM. Yeah, right now we see that the migration process has started. Okay, we see that the Oracle Linux Virtualization Manager is finalizing actually the overall migration process, and notice that in the task console we have also another unmount operation automatically executed. That's because for the migrated virtual machines, they no longer have mounted backup entry in here, so they are going to be unmounted, and virtual machine is actually the same as it would be restored using the regular restore mechanism. So here in the Oracle Linux Virtualization Manager, notice that the temporary instant restore domain is actually being deactivated currently by the OLVM. Here it was successful, and here as well. So it disappeared from the mounted backup section. Now, you don't have to restore whole virtual machine actually to restore individual files, and there is option to mount on the file system level, so file level recovery, the backup directly in the Storware Backup and Recovery. So let's mount file systems automatically in here. Now this again creates a new workflow. This one is called mount, and because we are using synthetic backup destination, file data is already merged underneath, so the process of restoring is instant, and we only have to mount it on the node so that you are able to browse and download the individual files. So let's wait, it's actually being mounted right now. Okay, mount operation has succeeded. So now here in the details, notice that I have everything mounted as a single root file system. I have only one disk. Here in the details you click browse, and now you are able to browse and download individual files. For instance, you would like to restore, let's say, bash rc. So that file comes actually to your drive. You also are able to invoke remote upload. It's going to actually create an archive and upload over the SSH to remote host. So sometimes it's easier to, instead of downloading data directly to your machine and uploading them again, just to use this mechanism and use specific credentials to upload a whole archive and files directly to your remote host. Now, there are other types of policies available in the Storware Backup and Recovery. Actually, one of them is snapshot policies. So if you would like periodically to create additional snapshot on your hypervisor manager, then and rotate them automatically, actually, you create snapshot management policy, and the vital thing here is to specify number of versions and number of days that snapshot should be kept on the hypervisor manager. We recommend to keep those values low, because that may affect your performance of the QCOW2-based virtual machines. Anyway, that's a supporting mechanism for general backup and for general data protection mechanism that you can use. Now, there is also the opposite policy. We call them recovery plans, and this recovery plan, let's call it, let's say, RP1, is able to define multiple rules. Here you add rule, which are for the specific hypervisor platform, for virtualization platform. So let's say that this is my prod environment, and I specify in this rule, in this individual rule, only environments of the specific type. So in my case, I have here only one type, it's oVirt, obviously, and I specify which environments I need to use. But if I would like, for instance, to create a single recovery plan for my, let's say, VMware and Oracle Linux Virtualization Manager recovery plan, then I can define two separate rules and execute them on demand or by schedule. Schedules are defined in here, but it's optional, because you may want to have a recovery plan only for the specific disaster recovery processes like batch restores, And to specify batch configuration, actually you need to have to go into this restore parameters tab, and notice that it is slightly different compared to regular restore. First of all, you define actually the source of your restore, the last successful backup or last regardless of status. That also includes your, let's say, failed backups. And the reason for that is that you may explicitly want sometimes to fail recovery and just to have them appeared on your report. So you have general policy to restore whatever you have currently available or not. Just give me last one, and it will try to use the last successful or last. If it's even if it's failed, it will be reported as failed. And in here you can specify restore to the hypervisor manager, which one, that's the common part. Then you may want to add some prefix for all of these restored virtual machines or suffix. Optionally delete environment if it already exists. If you are actually restoring virtual machine using the same name all the time, it would be an easy way to replace them all the time and have only one environment instead of more and more being added with every recovery that has been invoked. Now, once you have invoked the backup, you have to store somewhere the data. And with Storware Backup and Recovery, we have wide range of choices in here. The very commonly used actually is the file system synthetic, which gives you the most of the Storware Backups and Recovery capability. First of all, because it's synthesized, your restore is actually to take shorter. It's going to be instant in many cases because we don't have to merge data during the restore. Data is already merged and kept on your XFS or NFS for that 2+, because that's also the requirement. The reflink requirement here is the reason, or any other file system that supports reflinks, ZFS for instance. But we also are able to use data domain so for that, and that also gives you the ability to invoke secondary backup destination, so to replicate data. Now you notice here that we have also a regular file system. That's the one that doesn't support reflinks. So if you have such, like maybe you have older NFS, for instance, that's still fine, or catalogic vStore. Or isolayer. Isolayer is for ransomware data protection, to keep separate storage on the separate host, let's say, and using NFS we are able to mount dynamically only the volumes required for backup of individual virtual machines instead of having permanently mounted file system here. We also support object storage, so you can use S3 or S3 compatible storage if you would like to. Google, Microsoft is also supported, and OpenStack Swift, if you have, that's also supported. We can also add our partners, other vendors' solutions as the backup destination. So if you have IBM's, Dell's solutions, Veritas or Micro Focus, then also it is doable. And in this case, we are able to upload them data to those solutions. And finally, you have also tape support. So if using Tape Manager, you are able also to store data on your tape library, only if it's using generic SCSI driver to connect, and then it should be compatible. Finally, nodes. That's something that's in the middle. So on the left side of the picture, you have your source, virtual machines. On the right side, you have backup destinations, and Storware Backup and Recovery node is actually in the middle. You can group nodes in something called node configuration. Node configuration specifies you several things, actually, especially related to some minimum number of free space available for the snapshots. That's useful for the Oracle Linux Virtualization Manager, where we are able to make sure that before we take a snapshot, there is at least certain amount of space on your storage domains, on all of your storage domains that are related to the specific virtual machine that you are trying to back up. But also you have to sometimes to limit number of tasks per node, specify which backup destinations are allowed to be used for those nodes. So this is a description of your physical topology in this case. So in such scenario, scheduler will assign appropriate tasks to the nodes based on the availability. So if the node configuration is allowed to write to the specific backup destination, then you also are able to refer to that in the policy, for instance. So node configuration can later be assigned on the hypervisor manager level. That's what you already have noticed, but also that I already mentioned here on the hypervisor level. So if you want to scale your environment with multiple nodes, you later are able to add nodes to the individual set of your hypervisors inside your deployment. Last but not least, access management. That's also something that we have heavily worked on. This is especially useful if you would like to divide your backup and recovery team and give them, let's say, give access to the specific environments so that they are able backup and restore on their own. So here, whenever you have a role, let's say, you can define a new role. Notice that the roles have, well, system level means that they basically have all access to the specific sections of the application, but you can customize that and specify that you are giving only access to the virtual machines that, let's say, are specified, or to the all virtual machines that reside on the specific hypervisor. And then you define which privileges you are going to give. Virtual environments in this case, and you would be able to specify that users would be able to backup only, for instance. So role-based access control with support for object level control is also implemented in Storware Backup and Recovery. And this concludes my demonstration. As you can see, Storware Backup and Recovery gives you wide range options of how you can protect your oVirt-based environments. That gives you both on the backup destination side as well as the range of capabilities in terms of restore. We have seen how to do a regular restore, instant restore, file level recovery. You have also the recovery plans option if you would like to test periodically your backups. From the backup destinations perspective, you can choose not only file system, but also you are able to use object storage. That also includes cloud-based storage if you wish to, or attach your IBM, Dell, Veritas or OpenText data protector if you would like to proxy your backups to those solutions. Tapes are also supported in this case. Thank you for watching and stay tuned for the other videos.